Rusty, can you verify that the stream has started, please?
Stand by. I'm seeing it started.
Thank you. Participation is climbing. We're just about to tick over 900. Fantastic. We're about to start in less than a minute. Okay, it is top of the hour. Welcome to the Tree Fund webinar series. I would like to welcome you on behalf of the Tree Fund. My name is Bo Broadbeck, and I will be serving as your moderator today. I have the privilege to serve as the the chairman for the Board of Trustees for Tree Fund. And a few housekeeping items. Before I do that, this webinar is a little bit different from some of our other Tree Fund webinars in that we are partnering with ISA Southern Chapter. ISA Southern Chapter, like a lot of other conferences around the country, had to cancel their conference back in April, and they approached Tree Fund and asked if Tree Fund might share some of the keynote speakers they had scheduled to speak back in April. And so because of that, we will be bringing today Dr. Tom Smiley, and in a couple weeks, Dr. Kim Coder. So for those of you that missed Southern Chapter, you'll get to at least see the keynotes. And for those of you who had no intention of coming, you will still get to see the keynote addresses from the conference that was scheduled earlier this year. A few housekeeping items I would like to bring up before we provide an introduction on Tree Fund and Dr. Smiley is we are recording this webinar, and so you will be able to see this webinar at a future time. It'll be posted on the Tree Fund webpage. Please note that you can only get CEUs for this live recording. For CEUs, we will post the CEU code at the conclusion of this webinar. Please jot that down, take a screenshot, a picture of it, and you will use the self-submission form that you can either find on the ISA webpage, or if you go to the Tree Fund webinars tab, you can download that form and submit your own CEU. For those needing SAF credits, we will submit those for you. A couple other housekeeping items. We do have a chat box at the bottom of your screen. Please open that for those who haven't found it. If you have questions, type them in there, and time permitting, I will bring those to Dr. Smiley's attention at the end of today's webinar. So real quick, before I introduce Dr. Smiley, I'd like to introduce you to Tree Fund. I know that many of you have probably joined us, heard me say this, but Tree Fund is an organization that was created in a partnership between ISA and TCIA in 2002 to fund research in the field of arboriculture and urban forestry. They do this through grants for new research programs, and particularly applied research. So research that trickles down into the best management practices, into your ANSI standards, and a lot of times into things we use in the field. They also fund scholarships for aspiring tree care professionals and support education for K through 12 for that next generation of arborists that are coming up. If you want to learn more about the research that Tree Fund has done in the past, go to treefund.org, click on their research, go look at the research archives. You can see the grants that were funded since 2004 onward. You can see work that was published in 2018. It's a great place to kind of get up to speed, also to find speakers for conferences on new topics that you maybe haven't heard from. One of the things that we're trying to do at Tree Fund is disseminate some of the emerging research. And we're doing this through a webinar series. We've kind of bumped up the webinar series. Normally we did about 6 a year, but because all the conferences are being canceled, people are, looking for information, needing some CEUs, we bumped it up. So you'll get to see Dr. Kim Coder on June 2nd, part of our ISA Southern Chapter partnership, and then we'll go back to our traditional emerging research topics with Rachel Antwis on fighting microbes. We'll have Andrew Benson talking about protecting trees from construction and some of the research that he recently completed, I think last year or the year before. And then here are some of the other ones. It's too long to go into any of these, but a broad set of topics, a lot of good information out there. So tune in, take a look at those, sign up. We will be posting those links, usually a few weeks out for each webinar. And finally, I would like to conclude with just mentioning that the work that Tree Fund does is supported by people like you and I. We support Tree Fund through donations that allow these grants to happen. Grants available for the field of arboriculture and urban forestry, they're getting to be fewer and fewer, especially for doing applied research. Tree Fund is a great source of funding and seed money for a lot of those researchers. So consider donating to Tree Fund. If you think these webinars and the information you learn are valuable, it might be worth going to the Tree Fund webpage and clicking that donate button. Or you could support a Tour to Trees rider. I'm sure you can find somebody who's participating in Tree Fund's Tour to Trees, which is their kind of signature fundraising event. With that, I would like to introduce today's speaker, Dr. Thomas Smiley. He is an arboriculture research at the Bartlett Tree Research Laboratory in Charlotte, North Carolina, and an adjunct professor of urban forestry at Clemson University. He received his Master's of Science in Plant Pathology from Colorado State University and his doctorate in urban forestry from Michigan State University. Dr. Smiley, thank you very much for being here today. We have a great crowd for you out there, at least 1,000 joining us, so the virtual floor is yours.
Thank you, Bo. And we'll get right to the slide. So I'm going to be talking today about sidewalks, urban plazas, and tree roots. So we're going to be talking about getting the most out of our trees in limited areas and managing roots to reduce the number of conflicts with human activities. So to start with, we know that trees are most valuable where people work and live. And this is also the hardest place to get trees to grow. We know that not only is it hard to get trees to grow there, we need them big, but the biggest trees are the ones that really provide the most benefits. So our goal in many urban areas is to have large trees growing in those more difficult to grow areas. And we're going to be talking about some ways that we can do that. I'd like to start off with this diagram from Jim Urban, the landscape architect. And he shows us 6 things that are critical for tree growth in these urban areas. So starting with sufficient soil space. And we're going to be coming back to that multiple times today, but we have to have enough soil volume for those roots to grow in to get a large enough crown. We also have to provide space for that root flare to develop, and we know this is often problematic in downtown areas with tree grates and things like that. We need to have a source of water, both coming into the soil and leaving the soil. If it just stays in there, that is a major factor that leads to mortality in central business district areas. We also need room for that canopy to grow. Certainly we can do some pruning if we need to, but we need a sufficient amount of room for growth. And then finally, his last element here is quality nursery stock. And I know the nursery industry is trying to improve what they're growing, and sometimes we, as planters of trees, need to correct that material before it goes into the landscape or in years after it's planted. Going back to the theme of soil volume, I think most of you have seen this graphic. Again, this one I borrowed from Jim Urban, but it was contributed to by Dr. Nina Bassick and Dr. Ed Gilman. And what it shows is that you can predict the tree size based on the volume of soil that you have to grow the tree in. So in this case, we're showing a red line at 1,000 cubic feet, which should result in a tree that's about 16 inches in diameter. Well, in today's talk, I'm going to be talking about 3 different research projects. The first one, we're going to have a soil volume of about 200 cubic feet, which should result, therefore, in a tree about 4 inches in diameter. My second study has about 50 cubic feet of soil, which should result in a tree about 1 inch in diameter. And finally, we're going to go out into the real world of uptown Charlotte, North Carolina, where they tried to provide about 1,200 cubic feet of soil, which should result in about a 20-inch diameter tree. Okay, so how can we get this much soil in an urban area, whether it be residential or the central business district? Well, to look at some of our options here, back in 2004, we established a research plot with root barrier fabrics. In this case, it's a combination of a geotextile and a biobarrier to confine the root growth. This was the 200 cubic feet. We planted trees in there. We compacted the soil to support the weight of the pavement. And then we planted our trees and covered the whole area with concrete. And you'll see it's a relatively thin layer of concrete. We're only about 2 inches thick around the tree. Gets a little bit thicker at the edge where the pavement is more likely to get run over by vehicles. So this is the plot after it was installed. We've got 2 species of trees in there. I'll show you those in just a minute. And here are our treatments. We had a concrete supported pavement. Oops, looks like we're behind on the screen. We had a compacted soil treatment. This was a sandy clay loam, as all our soil is here, sandy clay loam, compacted to about 95% Proctor, a gravel-based structural soil, and an expanded slate structural soil. That is just like the gravel-based structural soil. It's a mixture of 80% gravel and 20% soil. The expanded slate was a little bit smaller than the gravel. Bo, are we keeping up with the slides? It looks like that is lagging behind on the screen. Okay.
I'm seeing Urban Plaza trial as your slide.
Yes, I'm 2 slides ahead of that for some reason.
Tom, you might unshare your, turn your video
stop
on.
and restart.
It might be a web connection issue.
Okay. Okay. Yeah, there we go. Okay, so just a few words about gravel-based structural soils. Again, these were developed by Dr. Nina Bassick and Dr. Jason Grabowski. And what they are is a collection of gravel and soil in between the gravel particles so that the load on the surface is transmitted from gravel piece to gravel piece, and the roots are allowed to grow through the soil around the rocks. The supported pavement systems are quite different. We start with a non-compacted soil, put gravel on top of that. And then this first research project that I'm going to be sharing with you has concrete posts that support a concrete deck. The trees planted in there, and we hopefully will get root growth out of that. Well, this is our plot after the first year. We already have some differences here. And let me point out a few things about this. Each subplot is 4 trees composed of 2 bosque elms and 2 snowdrift cherries. And they are replicated with different treatments. The first row, because of the different construction technique, was all the supported pavement. And the other treatments were randomized throughout the rest of the plot. You can already see some differences here in year 1. The expanded slate soil, or the expanded slate itself, had a quite high pH at 8.5. So those trees almost immediately went chlorotic. And that issue has been solved by those manufacturers who now rinse those soils before selling them. At the end of the first year, we looked at things like twig growth, dieback, and root length. We had some rhizotrons in there, which are glass windows in the side of a trench, so we could measure that root length. So let's start out with the twig growth. Here we had about twice as much twig growth with the supported pavement. With crown dieback, we had about twice as much dieback with the compacted soil. And over at the rhizotrons with the root length, we had about twice as much with both supported pavement and the gravel soil mixture. Here we are in year 2. We started treating those expanded slate trees, so we're correcting that nutrient deficiency that we saw in the first year. And I think you can start seeing some other differences developing. Here we are about 2.5 years out. The expanded slate product by itself, 100%. The trees are not doing particularly well there. I think you can see the supported pavement trees are doing pretty well. At 3.5 years, the trend is continuing. And then at 4 years, we decided to pull out the 100% expanded slate treatment and replace it. So we're not going to be looking at the data from that plot anymore. And we've also at this point removed the cherry trees because we were getting a higher mortality rate than we'd like, and we wanted a little more room for those crowns of the elm to grow. So we've replaced all the cherries with magnolias, so we can see some differences in the winter as well as during the growing season. So here we are 5 years out, and again, you can see that the differences are continuing. 6 years, 7 years, 8. We're going to 8. But before we get there, we also monitored under and within the concrete, the soil moisture levels and the temperature levels. So I wanted to share with you today the temperature level. So this is Charlotte, North Carolina in September, a pretty nice month here in Charlotte. We're only hitting about 90 degrees Fahrenheit and dropping down to about 55 degrees Fahrenheit. So these are the air temperatures. You can see the diurnal fluctuation, hot during the day, cooling off at night. And this is the temperature sensor from within the concrete. Now we're now going up to over 100 degrees Fahrenheit, dropping down to about 60 degrees at night. This is the urban heat island effect, that we're much hotter in that concrete and we're giving off that temperature, especially at night. Now, if we're going to shade that concrete, which a lot of our plots did provide shade, in that shade we cut back that high temperature by nearly 10 degrees, and we're still giving those temperatures off at night with the concrete temperature only dropping down to about 70. 6 inches under the pavement where the tree roots are growing, you can see still some diurnal fluctuation, but not getting as hot or as cool. We also had a temperature sensor outside our plot in the mulch layer, and here you can see a much more consistent temperature, which we think is better for root development. So it's warm there, but much more consistent. Well, back to the main story. Here's the plot at 8 years. We're now getting crown closure here. We're getting a lot more shading on the concrete. And 9 years, and then we stopped collecting data at 10 years, and I'll show you that data now. This is all just elm trunk diameter growth. You can see that the supported pavement was the treatment that produced the largest diameter treatments, or the largest diameter trees. And if we are looking at height, even a little bit greater difference here, that it was significantly more growth with that supported pavement. So our conclusions here were that the supported pavement treatment provided the best growing condition for elms. Since then, there have been a number of new developments with the soil mixes for use under pavement. So we wanted to take a look at some of these. So in 2014, we established a new plot. This plot was smaller than the original plot, so less soil volume. And like the initial plot, we have an under pavement drainage system. We have bottomless wood boxes. These boxes are 5 feet by 5 feet and about 18 inches deep to correspond with the height of one of our treatments. We also very carefully lined each of the boxes with a Typar geotextile to reduce root escape. Okay, and then we installed a number of treatments in that plot, and our treatments here, again, were a gravel-based structural soil. You'll see it with the initials GBSS, sand-based structural soil, the segmented cell system, and I'll give you more details on that in a second, a cell-supported pavement, and a compacted control, and a non-compacted open control. So this is the gravel-based structural soil, again, a mixture of 80% gravel, 20% soil, and the soil we're putting into all these plots was the original soil that we took out, so it's a sandy clay loam. We compacted it to 95% Proctor in about 8 or 10 inch lifts. The sand-based structural soil, we were relying on one of the consultants who sells this product, and following their directions here, they wanted a layer of gravel above the geotextile but below the sand. I'll go into the sand mix in just a minute. They wanted a ring of irrigation, unlike the other plots that just had irrigation in the opening. And again, these were compacted to 95% Proctor as well. The sand mix, the concept of this started with Els Kolberg in the Netherlands with the Amsterdam tree soil. back in the early 90s. Works very well over there, still doing very well. And it was sort of combined with the U.S. Gulf Association greens mix, and it's a little bit closer to the greens mix, being medium and coarse sand with some fines in there and some organic matter. One of our cellular treatments was the Silvacell from Deep Root Corporation. Here we are filling that. It has a different top here when you're filling it to hold the supports upright, and then you put a different top on that when you're done. So this is what it looks like when it's finished up. They're putting soil on the top of that, and then we're just going to pour our concrete on top of that. I think they do it a little bit differently in municipal settings. This is the Stratacell, which is our cell-based structure from City Green. Their representative came in and installed it, and again, our plot depth was based on this product so that we could put 2 cells deep without cutting these cells from a depth perspective. And here we are filling those cells with our soil. This is our sandy clay loam with a little bit of organic matter mixed in. And as you might be able to see, a little bit of difficulty in getting that soil well distributed, especially on that lower layer of cells. So it goes in very easily to these top layers, but you'll see some of the issues as we go along with that lower level of cells. And we were trying to work that into the cells with a vibratory plate with water, and we still had issues there. We'll see. We did have an outside engineering firm come in and check the density on all our plots to make sure that we hit that 95% proctor level that they would require on a roadbed or the base of a municipal sidewalk. So because of the different levels of compaction in each of these treatments, different soil volumes were installed. Okay, so our non-compacted treatment, the lightest soil, had about 2.7 cubic yards, and the compacted treatments all had about the same at 3.3 cubic yards of soil, and the supported pavements were sort of in between there. We lose a little bit of space to the structure of the cells, but not necessarily a lot. So this is what the plot looked like while we were installing it. We have 2 different lines, and they each had 3 replicates of each treatment in the line. For trees, we decided to go with a tree species that's pretty sensitive to root injury. And this is a liriodendron. It's a Chinese liriodendron. And it came to us, as you may have seen there, as she was pulling the root system out of the pot, that the roots were all in pretty bad shape. They were circling. So this is our research technician, Chris Bechtel, and she is going through each one of these and basically turning it into a bare root so that we can get, hopefully, better establishment. That added to the time, but I think it paid off. So after we planted, we installed the concrete. The plot here in the front is our open control. Everything else is covered with concrete. We do have irrigation systems installed for each tree. At the end of summer 2015, we started seeing some pretty significant differences in tree growth. And one thing that researchers like to see is that the treatments were based on the treatment and fairly consistent from treatment to treatment. So again, at the end of that first year, we took pictures of every tree, but what I'm showing you here is the middle tree, not the biggest, not the smallest, but the middle tree for each treatment. And I think you'll see as we go along that the results here are pretty much going to tell you the results at the end of the research trial. So here we are, our second year, and you can see again big differences in tree growth. We've got some really small trees, some really big trees, and again we've all got the same volume. They're all getting the same amount of water, even if their irrigation systems are slightly different. Oops. We also notice subsidence, that is soil moving away from the bottom of the pavement. This can be good or bad depending on how you look at it. From a good perspective, it means that the top of the roots are going to have some space to enlarge. So we would anticipate that the pavement is going to last a little bit longer if there is a little bit gap between the soil and the pavement. On the other hand, in an urban area, if we have a couple inches gap, we're going to have some unwanted urban wildlife, namely rats and snakes and things like that. And there were some pretty large and significant differences here in that subsidence. The compacted controls and the heavily compacted soil treatments had very little, and the looser the soil, the more subsidence we had. Now I mentioned to you that we had some issues with the stratocell and not being able to get soil into those lower levels. Well, the soil did get into those lower levels, but it took a little time. The problem was that the soil was redistributed after heavy rain. So it washed out of the upper cells and into the lower cells, leading to some pretty severe subsidence. And we had to actually replant those trees a couple of times because of the subsidence. The trees kept getting lower and lower in that plot. And I think that's reflected in the subsidence number at this point. Well, at the end of 2015, we were seeing some pretty significant differences, and this is a height change, or change in tree height, and the silvocell and stratocell were both giving us very good height increases. On the other end of the spectrum, the compacted control was growing much more slowly. At the end of the experiment, you can see the different tree diameters. This one's in inches, and we had significant differences here between treatments, but the stratocell, the silvocell, and the open control were significantly larger in diameter than the compacted control or either of the soil-based structural soils. So I think this is pretty much what you saw in those earlier pictures of what was doing well and what was not doing particularly well. In the fall of 2017, we decided to harvest the experiment. So we started out by removing all the leaves from the tree. It was fall, so we didn't have a whole lot to remove, but we wanted to finish that job up. And then we cut the tree off at the base and remove the pavement from the site. So we're trying as carefully as possible to lift those slabs of concrete. We've cut them along the treatment lines, halfway between the treatments. and then we're lifting them off so that we can get to basically an undisturbed root system. And this is what those root systems look like immediately after we took off the concrete. So here in the upper left, we have a gravel-based structural soil. Below that, we have the silvicell, and one of the decks has been loosened here so that you can see the soil around that plastic deck. And then we came in, and with high pressure air, high pressure water, and a few hand tools, we dug those root systems out. And you're starting to see the differences in the root systems here between the gravel-based structural soil and the silvicell. Pretty significant differences there that will be borne out in the numbers at the end. So we collected the fresh weight of the tops and of the root systems. And again, we included that top stump above the root collar with the trunk, even though that was a separate piece of wood. We weighed those and separated them out. Here are just a couple examples of the end product with the root system exposed. So your sand-based structural soil, we have the original root ball here, and then a few roots growing out at the very surface of that treatment, and you can see the spread in the next picture down below with the sand-based structural soil. With the silvicell, we had much better distribution of that root system throughout, so the initial root ball here, but we're getting lateral roots growing from all portions of the root ball, and you can see that spread as well in this top view. Well, here's a summary of the data we collected. You can see a couple of interesting things right here. One, we had two different groups is what it broke into. We have the supported pavement with the stratocell and the silvicell, giving us significantly more both top in green and roots in tan weight. The open control was right there with the stratocell. And it was also, I thought, very interesting to note that the weight of the tops was approximately equal to the weight of the root system. So start thinking about that. If we have equal weights of tops and roots, where are all those roots going to be down below soil? So those were our high performers, the stratocell, the silvicell, and the open control. On the other end, we had the compacted control, compacted sand, and the gravel-based structural soil. So if you want to get more details on this research, it has been published in Arboriculture and Urban Forestry back in 2019. Well, my last project on the pavement side is this one. This is Uptown Charlotte, and if you've ever been to Uptown Charlotte, you'll see some very large trees, willow oaks, lining the main uptown streets. But they were starting to decline a few years back, so the city asked us to come in and see if we could figure out why, sort of thinking that the decline may be due to hitting the top of that envelope with regards to soil volume. So this is their planting detail from the city of Charlotte, about 1,200 cubic feet here, and they are supporting the pavement. So the pavement is here. They're supporting it from basically a lip at the fronts of the building and the curb line along the street, and then a soil mix in between. So they're not doing it with concrete pillars like we did in our research, or plastic in the second project, but going from building front to street side. And we also had the opportunity looking at these trees to look at a neighborhood in Charlotte that was planted the same year with the same species from the same nursery. So that's the Ridgelock neighborhood here. We were able to measure both the uptown trees and that suburban neighborhood tree population. We looked at DBH, at height, and a crude estimate of condition. So this was 30 years after the tree planting was done. So uptown, our average DBH was 18 inches, average height 70 feet, and the condition was good to fair. So not really in the best of conditions. We looked at 151 trees uptown and 161 out in Ridgelock. And what we found was quite interesting to us. We were expecting the Ridgelock trees to be quite a bit larger and healthier than the uptown trees. And indeed what we found was that the diameter and height was the same statistically, but the difference was in the health condition of those trees. So we did a little more exploring here and found that that condition, not being as good uptown, was basically due to some biotic problems. They had a lot of Leucanium scale and Phytophthora root rot. Both which are of lesser importance in the residential area because of more predators and parasites, we would assume. So the overall research results is the trees with the greatest growth were those with open soil surfaces, supported pavement, and the product here didn't really matter. They were all very successful, whether it was concrete or plastic. We had the least amount of root growth with the structural soils, either gravel, expanded slate, and the compacted soils, including the sand-based and loam. Okay, moving on kind of quickly to our next topic is roots and sidewalks. How do we reduce damage by roots from to the sidewalk? So we have root growth under the sidewalks because there's moisture there. We get condensation on the bottom side of the concrete. There's oxygen there, especially if there's any settling or subsidence of the soil, and if there's nutrients and if the density allows growth, we will get root growth there. Roots can crack concrete, but we think that most of the cracks are formed before the roots grow, but water and air enter those cracks, and then the roots take more advantage of the cracks. So some sidewalks have pretty good conditions for growth underneath them. And if, as in this picture, we are close to the tree trunk, so we're in that zone of rapid taper, our tree trunk in the photo is right there against the concrete, we can get some pretty serious problems very quickly. So this trial we started back in 1996. And this is a suburban sidewalk. It's not an urban uptown sort of sidewalk, but suburban. So in this area, what they do for suburban sidewalks is they scrape the soil, frame it up with 2x4 lumber, and pour the concrete. What we did to be a little bit different is we installed treatments either underneath that concrete or alongside the edge of the sidewalk. Okay. Here are our selection of treatments. We went with the deep root linear barrier. In this case, we were using an 18-inch deep barrier. We were also using a black poly. So this is hardware store black poly. And we cut it to 18 inches just to have consistency in that depth. And both of those were installed alongside of the sidewalk. Underneath the sidewalk, we installed styrofoam boards. We wanted 4 inches of styrofoam, and we did that with 2 2-inch thick boards that were then glued together. We put down a 4-inch layer of gravel, a number 57 stone, and then a structural soil. Again, a gravel soil mix, 80% gravel, 20% soil, and that was in a 4-inch layer. The developers of the structural soil never intended that product to be used in this thin of a layer, but we have seen it used in that thickness on some of our client properties. So we wanted to see the impact of that thin of a layer. And again, we would never recommend that thin of a layer. And then we did a untreated control so you could see what would normally happen in the sidewalk. So here we are 4 years later. Again, we're trying to get as much growth out of these trees as we can. They are London plane trees, and we are mulching them, we are fertilizing them, and we are irrigating them. And you'll see that we tried to install these absolutely as close to the sidewalk as we could. So we put the edge of the root ball right outside the edge of the sidewalk so that we wouldn't have to wait any longer than necessary to see the damage to the sidewalk. And here we are at 10 years after planting. The trees have grown substantially by this time, and we are getting cracking and lifting of that pavement. So after 10 years, we decided it was time to remove the pavement. So again, we had our contractor in and he cracked the pavement with his backhoe, carefully lifted it out of there so as not to disturb the root system below. And then we came in and excavated the soil about 8 inches below the bottom of the sidewalk. We were using high pressure air, which didn't cut rapidly enough, so we switched over to high pressure water here from a fire hose, and we also used a pressure washer to get the roots exposed. What you can't see over here in the lower left-hand side of the picture is a Vector truck that is sucking this mud slurry out of the trench for us to let us expose the roots. So I'm going to show you a series of pictures as we go along. And the first picture is typically what it looked like immediately after we remove the pavement, and then an air excavation picture, hydro excavation, and so on. With our control, we had a lot of lifting and cracking of the pavement, and when we remove the concrete, you can see right off that those roots are directly beneath the concrete here in contact with the concrete, and that's why they're lifting so much. When we air excavate, you can again see those roots that were directly below the concrete. And then when we hydro excavate, you can see many more roots down below that surface layer. With the gravel soil mix, when we initially pulled the concrete, you don't see a lot of roots right there. But if you were to brush that off, you would find typically about 1 piece of gravel, a layer of 1 thick below the concrete above the root system. So here we are after we've air excavated that, and you can see the roots right below the concrete. And here we are with the hydro excavation. And we'll come back and talk about root size and location in a little bit. So here is our control in the foreground. You can see a lot of roots growing there. And this is the gravel soil mix, which is fewer roots, I think you can see that, but they're larger in diameter. So the roots really took advantage of that gravel soil mix, grew right across in that 4-inch layer over to the opposite side. From the opposite side, they're collecting nutrients and water and growing quite a bit larger and feeding those trees with the water and nutrients. So the black poly, this is immedately after we took the concrete off. You can see not many surface roots here. When we hydro excavated, you can see a few roots coming up. Here's one that went under the plastic, came right back up, another one here. So underground, this treatment worked quite well, and it was very inexpensive. The problem is with any of these soft root barriers is that they tend to deteriorate at the top or get mulched over or get soil over the top of the plastic. And when that happens, roots can quite easily grow over the top, as this one did. And that one really grew fairly large in diameter and started lifting the pavement. So while underground, this is quite a good treatment, it's that top edge where we start having problems with the treatment. That problem was not nearly as bad with a rigid root barrier. Here the example is the deep root linear barrier. And again, the roots grew underneath it. Some of them did come right back up in this sandy clay loam soil. But what we didn't have here was roots growing over the top. So that ended up being one of our best treatments. So here we are with a control treatment in the foreground. You can see the trunk of this tree is on the right, and the root grew around that root barrier to take advantage of the soil on the opposite side. Not many roots really coming up from below that barrier. The styrofoam treatment was also quite effective. It did force the root growth down deeper. You can see some fairly large roots, but now they're 4 inches below the bottom of the concrete. So we have gained 10 or maybe 20 years of sidewalk life by putting in that 4-inch buffer. And as these tree roots grow, especially this one, it did crush the styrofoam. But again, it gained probably 10 or 20 years on the life of the concrete surface. So here's another shot after the hydro excavation. In this one, the roots are a little bit more spread out. So that was another one of our best treatments. And we had a few roots that actually penetrated our glue layer between, this is the lower layer of styrofoam and the upper layer has been removed here. So we were able to harvest these roots and the styrofoam and send them to Dr. Jason Grabowski at Rutgers University, where he was measuring root pressure. So he was able to take these roots and calculate how much force that they were putting on that concrete surface. And his paper is also in arboriculture and urban forestry, if you want to look more into those details. So in the foreground of this picture, we've got a styrofoam treatment, and in the background, we have a control treatment. You can see quite significant differences in that root development. And we saw this with the gravel treatment as well, where many roots would grow maybe halfway across, and then a sinker root would develop. Here's a nice example of a sinker root right there, and here. And those roots would grow straight down and actually not make it across to the other side of the sidewalk. So here was our washed gravel, again a number 57 stone. It's about 1 inch or 1.5 inches in diameter. It does not have any fines, so it does not hold water or nutrients very well. And because of that, again, the roots would try growing across, and then they'd often switch over to a sinker root and descend very rapidly. So again, this was one of our best treatments where we saw fewer, smaller, and deeper roots. So what we found was the best treatments for reducing sidewalk lifting under pavement were gravel, the styrofoam, and the deep root barrier. There are many other barriers available. We do have a paper comparing the different barriers. In this experiment, we used the deep root product and it worked very well. There are other options there as well. So a lot of people will see that and say, well, can we put some of those treatments together and get even more life out of our sidewalk? And I would say, yes, you certainly can. And I like this diagram from Rob Burke, who's a engineer, and this is from an interlocking paver magazine where he had written an article on this and basically combined a couple of the treatments that we were looking at. Here he's combining gravel layer, a geotextile layer like the Typar that works very well at excluding roots. And he has this edging here that it would be basically the same thing as a root barrier. So that combination is going to provide a very long lasting, in this case, interlocking pavers, but it would also work with sidewalks or other surfaces like that. And it has the advantage of being able to store a fair amount of stormwater. So if stormwater capture is part of the equation, this can be a very good way to go. Okay, well, we've published our research results. This was 2008 in arboriculture and urban forestry. We also have a comparison paper on the different types of root barriers that are available to you either in the short run. We did a 3-year and a 7-year experiment. And Dr. Ed Gilman has a very similar project that he completed down in Florida. So if you're in those tropical or semi-tropical regions with a lot of rain, Dr. Gilman's research may be more applicable to your situation. Well, with that, I'm going to get to the end and just mention a few references that you might want to look into if you're interested in tree roots and soil. The ISA has a series of best management practices. So these are relatively short publications that get very quickly to practical applications. The one I'm showing you here is Soil Management for Urban Trees. Dr. Bryant Scherenbrock is the senior author on this one. It talks about soil sampling and profile analysis and things like that. We also have one on root management with Dr. Larry Costello and Dr. Gary Watson on that one, fertilization, and many other topics. Jim Urban's book, Up by Roots, is a very lengthy publication, goes into much greater detail on all aspects of tree roots, so an excellent reference. Dr. Larry Costello and Catherine Jones have Reducing Infrastructure Damage by Tree Roots, a compendium of strategy. All of these publications are available either through your chapters or ISA International. We greatly encourage you to support your chapters in these hard economic times whenever you have the chance. So with that, I'm going to turn it back to Bo, and he will wrap it up. So thank you for attending today, and thank you, Bo.
Tom, thank you very much. Fantastic presentation. I've been looking at the comments, a lot of positive comments there. A lot of questions as well, and we only have about 3 minutes. And I know some of you listening have other places you need to be, so I'm going to do a couple things here real quick. The first thing I'm going to do is I'm going to go ahead and share the CEU code for those of you that need to get on with your day. To do that, I do have to pause the recording.